The lesson topic for this video is properties of exponents. We're going to talk about 4 rules of exponents today and then practice them. First of all, the product rule. The product rule says that if you have a base of x, hold on one sec, here we go. If we have a base of x raised to some exponent, let's call it m, and then we multiply that by the same base, so x, again, raised to a different exponent, let's say n, then the result will always be that we can keep the base of x and we can add the exponents. So m plus n. We'll look at an example of that in a little bit. The second rule is the quotient rule. Quotient means the answer to a division problem, so division here. The quotient rule is similar in that it says that if I have a base of x raised to a power, let's say m, and I divide that by something with the same base of x raised to the nth power, that we can simplify this because they have the same base, we can keep the base, and then we can do m minus n. The power rule says that if we have just a single base of x and it's raised to a power, again m, and then that entire base and exponent is raised to another exponent, that we can keep the base of x and this time multiply the exponents m times n. So just to make sure this is clear on your notes, this is m plus n here, m minus n here, and m times n right here. The last rule we're going to talk about today in these notes is the zero exponent rule. The zero exponent rule simply says if we have a base and it is raised to the exponent of 0, the answer to that will always be 1, like the number 1. And I stress that because a lot of times people will change this to x to the first power or 1x, but it's really just the number 1. All right, let's try some examples. All right, so our first one, number 1, x squared raised to the third. What's going on here is we have a single base and it's raised to 2 exponents. If you remember from the previous page, that is the power rule. So that means leave your base of x and then take your exponents and multiply them. Most of you wouldn't probably have to show that work right there. You could just simply say this would be x to the 6th. The next example, we have x to the 5th power over x to the 3rd power. This is the quotient rule. They both have, again, the same base of x. So when we simplify this, we will keep our base of x, and then we will subtract 5 minus 3. Notice it is always the exponent in the numerator minus the exponent in the denominator. So 5 minus 3, which means that x is squared, 5 minus 3. So x squared is our answer to this one, or our simplified format. Number 3, x squared times x to the 5th. Again, we have a base of x and another base of x. We're always looking for like bases, and they're being multiplied. And because the bases are the same and they're being multiplied, we add their exponents. So we're going to have x raised to the 2 plus 5 in this situation, and 2 plus 5, of course, is 7, x to the 7th. Number 4, need to be kind of careful here. We have 5 times x to the 0 power. Think for a minute about what is being raised to the 0 power here. It is just the x variable. If it was the whole thing, it would be 5x raised to the 0 power. That is not what we have. So our 5 remains the same, and x to the 0, we just said on the previous page, x to the 0 is 1, the number 1. So times 1. because notice in between the 5 right here and the x right here, multiplication is in between there. So I'm going to put that multiplication sign here, and 5 times 1 is 5. So our solution here is 5, or our simplified answer. That is a different problem. In fact, let's just take a gander at this one for a minute now that I did that. What would 5x in parentheses all raised to the 0th power be? Well, this is saying that this whole thing is being raised to the 0. Again, what we said for the 0 exponent rule is that anything raised to the 0 power becomes 1. So this is simply 1. On this page, we have some more complex examples using these rules. As you can see, these are different than the previous page, but we're going to be using the same rules. The first one says 3 times x to the 6th times 4 times x to the 10th. Now, as you heard me read that, you might realize that what I was saying for right in between here, the 3 and the x, I was saying 3 times x to the 6th. Because remember that when two things are right next to each other, that does indeed mean multiplication. So if I wanted to rewrite this, and some of you might want to because it'll make more sense to you, 3 times x to the 6th times 4 times x to the 10th. Sometimes people like to think that this term and this term stay like as two, they're not terms, I shouldn't say that, but this part right here and this part right here, people like to think of them as terms that are stuck together, and that's not the case. This is actually one long string of multiplication. So that's why I rewrote it like this. So now how would we simplify this? Well, using the rules we've learned on the last couple of slides, we have a base of x right here and a base of x right here. Since they are both a base of x, we can write our base of x right here. And then what do we do when we have two bases of x and it's being multiplied? Well, we add the exponents. I'm actually going to back up just one second here and say we could also rearrange this long strand of multiplication. We could write 3 times and then bring the 4 up and then times x to the 6th times x to the 10th. This might make a little bit more sense to some of you. So in the front we have 3 times 4. Well, 3 times 4 is 12. Now here's where I was talking about we have that base of x and the base of x. If we have the same base and they're being multiplied, that is the product rule. So we leave our base of x and then we add the exponents. So 6 plus 10. This is 16. So 12 times x to the 16th. The next example is again a long string of multiplication. It doesn't matter that these two are, one's a number here and this is x to the 5th, they're being multiplied. Between the x to the 5th and the y to the 2nd, they're being multiplied. And even right here between the parentheses, this is multiplication. Since there's no adding or subtracting anywhere, we could rewrite this as negative 2 times x to the 5th times y squared times 3 times x to the 5th times y squared. And now we can rearrange it if we want to, or just go ahead and simplify by using multiplying things that have the same base. Again, some of you aren't going to need this step I'm about to show. Go ahead and skip it, but I'm going to go ahead and rearrange so that my number factors are first, so negative 2 right here, and then the 3 right here. Then I'm going to put my x, my terms with a base of x, so times x to the 5th, and then times another x to the 5th. Then I have a y to the 2nd power here and another y to the 2nd power here. So times y to the 2nd times y to the 2nd. So now if we do our multiplication, we have negative 2 times 3 right here, that's negative 6. We have a base of x and a base of x. If we have the same bases, we add the exponents, so 5 and 5 is 10. And then we have again base of y and base of y right here, and then that means we keep the base of y and we add the exponents, which is 4. So negative 6 x to the 10th, y to the 4th. All right. This next one is a little bit more complex because we have a 3x squared all being raised to the 4th power. The first thing we need to do is remember that when a factor like 3x squared is being raised to the 4th power, every factor within those parentheses needs to be raised to the 4th power. So this 3 needs to be raised to the 4th power, and this x squared needs to be raised to the 4th power. So we're going to write 3 raised to the 4th, and then we're going to write x squared raised to the 4th. In the denominator, we have 6x to the 3rd, like so. Now, 3 to the 4th power, which is right here, is 3 times 3 times 3 times 3. Well, 3 times 3 is 9, and the other 3 times 3 is 9, so 9 times 9, that's going to be 81. So 81. The next thing we have here is x squared to the 4th power. This is the power rule. Okay, and the power rule says that if we have one base of x, we can leave that base of x, and then we multiply our exponents. So we need to multiply the 2 and the 4, and 2 times 4 is 8. Over 6x to the 3rd. Now at this point, we have to do a couple different things to simplify. First of all, we're going to simplify the fact that we have an 81 and a 6, two constant value numerical values. We can divide both the top and the bottom by 3. When I divide the top by 3, I get 27. When I divide the bottom by 3, I get 2. Now we're going to deal with the fact that we have a quotient rule right here, x to the 8th over x to the 3rd. So here what happens is our final answer is going to be 27 in the numerator and 2 in the denominator. And then dealing with this part here, we're going to have a base of x. Here's what I like to say actually here is if I were to write out this top part right here, x to the 8th, that would be x multiplied by itself 8 times. I'm just going to do that off here to the side quick. All right, so that'd be like, I don't have a lot of space. I'm going to do it here. 1, 2, 3, 4, 5, 6, 7, 8. In the denominator, I have 3 x's, right? Right here, I have 3 x's. So I could write 1, 2, 3 x's because x times x times x. Now, what I can do is I can cancel this x with this one, and this one with this one, and then this one with this one. How many do I have left? Well, I have 5 of them, x to the 5th. And where are they located in this fraction? In the numerator. So I have x to the 5th left in the numerator. All right. The next one says x to the 3rd over y to the 4th, all raised to the 7th. What this means is that we need to raise x to the 3rd power to the 7th, and we need to raise the denominator, y to the 4th power, to the 7th as well. Well, these are both power rules. If we have one base of x, we leave it there, and then we multiply the exponents. So 3 times 7 is 21. And then we leave the base of y, and we multiply the exponents. 7 times 4, and that's 28. Now, YouTube's going to cut me off after 15 minutes, so I'm going to cut this last one short and not do it. You can go ahead and try it if you write it on your paper.